Welcome to our video about our project for electronics and instrumentation. We will discuss the goal of the project as well as the methods we use to produce the desired outcome. The goal of the project is, and I quote from the project description, design an analog electronic feedback controller system that controls the velocity of a DC brush motor.
The first stage of the project is to create a potentiometer-controlled voltage source with a range of plus or minus 2.5 volts. The only inputs to the system are plus or minus 18 volt sources. To create a range of plus or minus 2.5 volts, we use Zener diodes with a reverse breakdown voltage of 2.5 volts. Coupled with resistors, these Zener diodes provided plus or minus 2.5 volts to the potentiometer. The potentiometer outputs the command voltage.
The second stage of the project is to create a motor velocity control circuit. DC brush motors have an output torque in direct proportion to their input current. The motor we used also had a tachometer that produced a voltage proportional to the angular velocity. The goal is that when the motor is at the correct speed, it doesn't require any torque and therefore no input current either. To accomplish the control, we use a differential amplifier followed by a voltage to current amplifier. The differential amplifier subtracts the tachometer voltage from the command voltage so that when the voltages are equal, there is no output voltage. That output voltage is VA command for amplified command voltage. VA command goes into the current amplifier, which powers the motor.
There are also three quality control monitoring circuits. The first quality control is supposed to monitor if the motor is running, forwards or backwards. This is accomplished with a comparator by comparing the tachometer voltage to ground. When the tachometer voltage is positive, meaning the motor is spinning forward, a green LED lights up. In reverse, the tachometer voltage is negative and a red LED lights up.
The second quality control monitors the motor speed. It is supposed to alert the operator if the speed falls below 10% of the desired value. We use another comparator to compare 10% of the command voltage against the difference between the command voltage and the tachometer voltage. If the speed is too slow, a red LED lights up. If the speed is within 10%, a green LED lights up. This circuit works when the motor is spinning in either direction.
The third quality control monitors the current going to the motor. It alerts the user if the current exceeds a quarter of an amp in either direction. We monitor the current by monitoring the voltage across a known resistor through which the current flows. Using another comparator, we compare the voltage across this 2 ohm resistor to 0.5 volts, which is the voltage equivalent to a quarter of an amp across a 2 ohm resistor. Under normal conditions, a green LED is on. If the current goes too high, a red LED turns on instead.
Go ahead. Okay, so here you can see our circuit that we're fully to the right, and so it's positive 2.5 volts going into the circuit. So this is the direction. You can see that it's forward. This is, both of these are green because everything's working well. And so now, this is the speed control and this is the current control, or current monitoring and speed monitoring. Speed, current. So when I slow down the motor with my hand, you can see that both of those lights go red because this means there's too much current to be safe, and this means that it's slowed down compared to what it should be. Now when I turn it to the middle, the motor stops. When I turn it all the way to the left, you can see that once it speeds up, this corrects itself back to green. This shows that it's going in the reverse direction, red. Now the same thing happens here. When I slow it down with my hand, both of these lights go red because it's too slow and there's too much current.